In this video, we're going to be going through how to use Dalton's law of partial pressure. We're going to be doing exercise 17 together. So exercise 17 says, mixtures of helium and oxygen are used in scuba diving tanks to help prevent the bends. For a particular dive, 40 liters helium at 25 degrees Celsius and 1 atm, and 12 liters of oxygen at 25 degrees Celsius and 1 atm were pumped into a tank with a volume of 5 liters. Calculate the partial pressure of each gas and the total pressure in the tank at 25 degrees Celsius. Okay, so we are doing two things in this problem. First, we are going to calculate the total pressure in the tank, and then we will calculate the partial pressure of each gas. To get the total pressure in the tank, we do P equals nRT divided by V. That's our ideal gas law. You may, if you don't recognize that, I want you to think this comes from PV equals nRT. All I've done is divide volume on both sides, so I get pressure alone. In order to calculate our total pressure, we need our moles, which we don't have. So this is a question mark. We're going to need to figure out how to do that. We have R, we have T at 25 degrees Celsius, and we have volume at 5 liters. So in order to calculate our total pressure, we need to figure out our total number of moles. So let's break down exactly what we have. So we have 46 liters of helium, 25 degrees Celsius, and 1 atm. And then we also have 12 liters of oxygen, 25 degrees Celsius, 1 atm. Well, using this information, remember, we need to know our total number of moles. So we're going to have some amount of moles of helium and some amount of moles of oxygen gas. So using our PV equals nRT, we know that N equals PV over RT. So let's take one gas at a time. So we're going to take helium. And we know that the pressure of helium is 1 atm. We know that the volume of helium is 46 liters. We are given R always, 0.0821. And remember that's an atm times liter divided by mole times Kelvin. And we are given our temperature, 25 degrees Celsius, so that's 298 Kelvin. So we can plug this into our calculator and we are going to get the number of moles. But remember, this is only helium. So after plugging this into our calculator, we should get that we have 1.9 moles of He. That's what N equals. Okay, so that's a number that we need to remember. So in this problem, again, we have helium gas and we have oxygen gas. So now we're going to take some time and we are going to do the same thing that we just did, but now we need to know how many moles of oxygen gas do we have. So again, we are given our pressure, we are given our volume in our problem, divided by our R, which we are always given, atm, liters over mole Kelvin. And our temperature is again 25 degrees Celsius or 298 Kelvin. Okay, so again, when we get the answer to this, we will be getting not our pressure, our moles of oxygen. So for this, our moles of oxygen, after plugging this in, hopefully you get 0.49 moles of O2. So remember, we are trying to find the total pressure. We needed to determine our N in order to find our P total. So P total is going to equal the N, which is our moles, but since we're doing the total pressure, we would do our total number of moles. So we are going to add our 1.9 moles and our 0.49 moles. We're going to add all of our gas moles, and hopefully you get 2.37 or thereabouts, depending on how you rounded. So we will have, that's going to be 2.37, and with sig figs, we would just use 2 sig figs. So 2.4 moles of our total gas times R, which is 0.0821, and remember ATM, liter divided by mole Kelvin, times our Kelvin, and again we're at 25 degrees Celsius, that's 298 K, all divided by our volume, which is 5.0 liters. So when we look at this problem, we see that liters cancel out, moles cancel out, Kelvin cancels out, so we will be left with ATM, which is our unit of pressure, so that's wonderful. So our P total is going to equal, once we put all that into our calculator, it should equal about 12 ATM. Okay, so that's the answer to one of these questions. That is our total amount of pressure that's in this tank. Now, once you have your total amount of pressure, you can find out the partial pressure of each gas. The way we do this is we use that equation that you hopefully see on the paper. The partial pressure of a specific gas, so we're going to call this gas A, is equal to the total pressure of all of our gases times the mole fraction. So the mole fraction means how much of our hypothetical gas A do we have in this total problem. So in this problem, we have 1.9 moles of helium. So we have 1.9 moles of helium out of our total moles, which is our 1.9 plus our 0.49. So our total moles is our 2.4 moles, and that's in total. So that will be our mole fraction. So that is how much of our total moles are just helium. And then we can multiply this by our total pressure, which we just calculated. And remember, our total pressure is that 12 ATM. So we will multiply this by 12 ATM to get our pressure, and this will be the pressure of just helium, which will equal, the pressure of just helium should be 9.2 ATM. And if it's off by a tenth, I apologize. During the calculations, I did not round when I put this in my calculator. So now we did helium. Now we need to figure out the total amount of pressure just from the oxygen. So that would be our 0.49 moles of oxygen divided by our total number of moles, 2.4 moles in total, times our total pressure, which is 12 ATM, and that brings us to 2.4 ATM. I want you to notice 9.2 plus 2.4 equals 11.6, and when we round that to 2 sig figs, we get 12, which is the same thing as our total pressure. So that's a way to check. So that is this problem. You should have 3 answers. You should have the total pressure of 12 ATM. You should have the pressure of helium, which is 9.2 ATM, and the pressure of oxygen, 2.4 ATM.